Okay.
I get to go cut down trees.
All right, so here we go. First of all, for the seniors, okay, the review sheet that is called Review 2-1 to 2-5, and you don't even need to know, it just says find the remainder of this. So one option, of course, to find the remainder would be to divide. But this would be a horrible problem to divide because of all the missing powers that there are in there. So remember, if all you want is the remainder, you can treat this like a function. This 3x to the 100th. Pretend it's a function. And then plug in the same number that you would have put in the box if you were dividing. So if you were dividing, what number would go in the box?
-1.
-1. So you're going to plug -1 into this function. So -1 to the 100th is just 1, so this is going to be 3. That's going to be negative, so that's going to be +4 minus 10. So the answer to the question is just -3. If you want the remainder only, because this doesn't give you anything but the remainder. If that's all you care about is the remainder, then you can just plug in whatever number you would have divided by. Okay? All right, that takes care of that one. Now, I need to look at homework 2.5. And if you have it electronically only, you can look at it there. Homework 2.5, number 1. It says, I got a polynomial that contains -2,4, and I have zeros at 1 and 1 plus I. Well, wait a second. If I have a 0 at 1 plus I also have a 0 at 1 minus I. And my job is to write the polynomial and multiply it out. So you know what that means. If you know the zeros, then you know what the factors are. What are the factors of this problem? X minus 1,
X
minus 1 minus I, X minus 1 plus I. You made this a -1, so make these negative, make these negative, which makes that one a positive, right? Now, it says multiply out. So I'm going to FOIL these two first. You got to FOIL. It always is easiest to FOIL the ones with the eyes. So here we go. First times boom, boom, boom. So x squared minus x plus xi. Now, -1 times boom, boom, boom. -x plus 1 minus I. And then -I times boom, boom, boom. So -ix, positive I, and negative I squared. Every I should cancel. If you have done this correctly, all the I's should cancel. There should never be an I in your answer. So let's see if they cancel. Does this cancel out? Yep. Does this cancel out? Yep. And what about that? That's +1. So we have x squared minus 2x plus 2 times x minus 1. So again, I'll take this times all 3. So x cubed minus 2x squared plus 2x minus x squared plus 2x minus 2.
I have a problem to ask you.
Yep, I got the hiccups. Now I'm going to simplify. I like my terms. So I have x cubed minus 3x squared plus 4x minus 2. Is that right?
Yeah.
So here's my polynomial so far. Right? What's missing? Well, before I ended up multiplying all this together, there was a leading coefficient out here, right? That's missing. How do I figure out what that is?
You plug in
I use that point up there. Now, where can I plug it in? Well, you can plug it in anywhere you want. You can plug it in for y and x here. I wouldn't recommend that because of the i's. You can plug it in here, or you can plug it in here. But somewhere you have to let y be 4. My n is here. So I have to let y be 4, and then all of the x's are -2. So that would be -8 minus 12 minus 8 minus 2. So what is that? -20, -30. So my n is actually -2/15. Now, in a problem where I'm not multiplying out, I can just erase this guy right here and put in -2/15 and I'm done. But since I'm directed to multiply it all out, I have to put my -2/15 here and then distribute it. So I'm going to get y equals -2/15 x cubed plus, now what happens when you multiply 2/15 times 3/1? Don't you get 2/5? X squared plus, actually minus, because now I'm taking 2/15 times 4/1, so that's 8/15, and then minus 2. So that actually is the final multiplied out answer. It's just a lot of work. It isn't hard, but there is a lot of work. Okay, so that was number 1. Now, they also wanted to do number 2. Now, the good news about number 2 is we don't have to multiply it out. So we're not going to have all this FOIL. Number 2 is a little bit different, though, because we've got to pay attention to the graph. Okay, Jackson, can you see? Is that thing going?
Yes.
Okay. So, we got to pay attention to the graph. So we're going to write the equation of the polynomial shown. Now, first of all, our polynomial is going to have 3 parentheses. How do I know that? This is number 2 on 2.5 homework. How do I know that there's 3 parentheses? There's 3 x-intercepts, right? I only look at the ones on the x-axis. So those parentheses will be x plus 3, x plus 1, and x minus 2, right? Step 1, get your parentheses built. Step 2, look carefully at the graph. If they give you a graph, look carefully at it. What is happening on the graph at the point -3, 0? Bouncing, which means that factor has to be squared. And isn't that happening again at the last x-intercept? The graph is bouncing. Everybody clear on that? Well, the last thing to do then is figure out that leading coefficient. So luckily, they gave us another point. This point does not go in the parentheses. Only the x-intercepts go in the parentheses, only the points on the x-axis. So 3 equals n times negative 4 plus 3 squared, negative 4 plus 1, negative 4 minus 2 squared. So I put in 3 for my y, yep, and negative 4 for all of my x's, right? And now I'm going to do work. So negative 4 plus 3 is negative 1, but it's squared, so that's 1. Negative 4 plus 1. And negative 4 minus 2, negative 6 squared is 36. So let's see, when I divide, I got 3 equal to negative 108n. So that's actually going to reduce to 1 over 36, isn't it? So this one is easy. I just can go back to my original setup and put in negative 1 over 36. And that's what I'll write in the answer blank. Right? Okay, that's it that was requested from the seniors. So now it's you guys' turn. What is requested from you?
I've got one.
Okay,
Find the zeros of 3, you want me to say it to you? 3x to the 4th, plus 8x to the 3rd, plus 6x to the 2nd, plus 3x minus 2.
find the zeros. All right, what are our possible rational roots? I just automatically went there. Obviously, that's not going to factor my grouping, right? Everybody sees that. So we're not going to mess around with that. We're just going to go straight to the PRRs. We're going to start guessing. What are our PRRs? Factors of 2 over factors of 3. So that's 2 and 1, but it's also 2/3 and 1/3. So those are the numbers that I'm going to guess. All right, so I'm going to start with easy. I'll try negative 1. I'm just like you guys. I'm guessing. I am not. Oh shoot! I thought that was going to work, but it didn't. Did I make a mistake? I was all excited there for a second. I don't think it works. Okay, so negative 1 didn't work. All right, so maybe I'll try negative 2. There we go. There's 1. So my job was to find the roots, you said?
Zeros.
Zeros, roots, zeros, all those mean the same thing, yeah? So we're at negative 2. So one of our answers is negative 2. Now, what do I do after that happens?
You put it back, it would be like 3x to the 3rd plus
Yep.
2x to the 2nd, so on and so forth.
So I look at what's left. And I was hoping, I want this equals 0, I'm going to find the roots of the zeros. I was hoping that I could factor my grouping, but that's not going to work. So guess what I get to do? I can do it again. However, this time, my PRRs have changed because now my end is a 1. So there's no longer a 2 here, which means there's no longer that one or this one. So now my PRRs are just 1 and 1/3, plus or minus. Now I already tried negative 1 and it didn't work. It's not going to work in this problem, so I'm not going to try that again. Positive 1 isn't going to work. I can see that things are just gonna keep adding up and not ever cancel out with this -1. Does that make sense to you a little bit, if you think about the division process? So I guess I'm gonna try, I don't know, -1/3, I guess.
So we need to find 3 more x's, right?
We're gonna have to find 3 more, yep. But if I find 1 more, then if I divide it out, I'll have a quadratic, and I can use the quadratic formula on it.
To get 2 more.
But I need to guess another one first, so.
Okay.
-1/1, this is gonna be -1/3, that does not look good. How about +1/3? 1, 3, 1, oh, this looks better. There we go, there we go. So another one of my roots is +1/3. And now what's left? 3x squared plus 3x plus 3. Now, if you want to divide out the 3, that's perfectly okay. If that confuses you, then don't, but that is a 0. So you can divide everything by 3. That doesn't factor, so I'm gonna need to use my quadratic formula.
Could you use the quadratic formula without dividing by 3?
Eventually those 3's are gonna all cancel out. But yeah, your numbers will be bigger, but you absolutely can, yep. So any quadratic equation, Peter, any quadratic equation you can use the formula on. So -b plus or minus the square root of b squared minus 4ac over 2a. So it looks like my other 2 roots, that's gonna be -3, right? So I√3. So it's those 2 and those 2 are the answers to the problem.
I was so lost on that homework last night. Did you see my work?
That's why you got a comment.
Yeah.
So this was just perseverance. This took a while. We had to just guess, but eventually it worked out.
Find the zeros.
Okay, so we did. We found the zeros. There's 4 of them. 1, 2, 3, 4. All right. Lauren, did you have a question for me?
Can we go over root 2.1 to 2.5, 13, number 13? It's asking
What does it say?
what price per copy maximizes income. There's
You probably better look
80,000.
at that one. Let me find the paper. So it's 2.1 to 2.5, you said?
Yeah.
And it's number 13, the publisher of a magazine. Okay, so the sheet we did yesterday in class, it's the back, just flip that paper over, and it's number 13. And it says we are making magazines and selling them. And we want to talk about our income. So right now, our income is 80,000 times $1.60. That's what's happening right now. I'm making 80,000 magazines and I'm selling them for $1.60. Okay? Now, it says that we're going to lose 10,000 readers for every 40-cent increase. So if X is the number of price increases, every time I have a price increase, I lose 10,000 people. So minus 10,000X. Every time I raise my price, I'll lose 10,000. Every time I raise my price, it goes up 40 cents. Now that right there is going to be a quadratic equation. Because when I FOIL it, I'm going to end up with a negative x squared, right? Which means I'm going to end up with a parabola opening down. The maximum is simply going to be the vertex, right? So we have 2 options. if this is a no calculator, I would recommend using the intercept option. But your two options are FOIL it all out, so you have ax squared plus bx plus c, and then find your vertex doing negative b over 2a, okay? That will always work. In this case, if I'm using my calculator, fine. If not, and I think this is the one, yeah, that's on the no calculator part. So if you can still multiply those numbers. You don't need a calculator to do that. But also remember, each of the factors gives me an intercept, just like all the graphing we've done. So when I solve that factor, 80,000 minus a fact 10,000 x equals 0, doesn't x equal 8? And if I solve this one, doesn't x equal negative 4? You guys might want to multiply it out if this is challenging you. But anyhow, so I got a parabola that looks like this. Don't I know that the axis of symmetry is right smack dab in the middle? So what's the midpoint of negative 4 and 8? What's the average of negative 4 and 8?
2.
Negative 4 plus 8 is 4, divided by 2 is 2. So 2 is right in the middle, so that's my x coordinate.
What's the other way to do that again?
Multiply it all out and do negative b over 2a. Now, let's read the question. What does this 2 stand for?
Price changes?
How many times I change the price, right? So I'm gonna raise my price twice. So let's see what the question says. What price should he charge? Well, what was the original price?
$6.
And he's gonna raise it twice, so it's gonna go up by 80. So the price he should charge is $240. Now, if I put 2 in here, I get 60,000. What does that stand for? 60,000 what? Magazines. He started out selling 80,000, right? If he increases twice, he's gonna lose 20,000. So if it said, how many magazines will he sell? The answer would be 60,000. If it said, what is his maximum income? That would be 240 times 60,000, or whatever y you get when you plug 2 into your equation. You'll get 60,000 times 240, whatever that is.
So, I have a quick question on the whole thing. Are we done with that?
Okay, so are we done with this, Lauren? Is that good? Okay, so what?
So, you said everything on this page was an exact question from the test? Right, this yesterday?
The concept, yeah.
Okay, so like back here, when I'm looking at velocity, volume, box problems, simplifying, and then, like is all that gonna be on the test too?
The box problems we have done a lot.
Yeah, I was just
So you
wondering.
need to know a box problem. And the velocity problem is no different really than this one, because what kind of an equation is that that's given to you?
Parabola.
Opening down. I bet it says something about maximum or highest
Yeah,
point. So what do?
plug everything in.
We find the vertex. And how do we find the vertex?
I can be over to
So I said the concepts are the same,
Okay.
not the verbatim problems. But if you have a parabola, if you have some kind of equation, and in that case you didn't even have to build the equation, it's given to you, and it's a parabola, and you want to know a parabola going down, and you want to know the maximum, you're just going to do negative b over 2a, right? That's how you find the vertex.
Okay.
We can do whatever, so I don't know.
Can we do, Jeff, do you have one?
The
You want
tennis score problem, like number 5.
Which one?
on this sheet, the 2.1, it just like 2.1 and then like there's a bullet thing right here, whatever.
So read the question you wanna do.
Number 5, Alex wants to fence in his court. He has
Okay, wait,
3.
I need to find that, that's it.
Should be on like the second or third page.
Okay, so that's on the one that was a quiz. It's an old quiz. And it says he's gonna build his fence or something around, here's his house, and here's this thing he's fencing. So this is the actual fence. And he has 300 meters of fencing, so the squiggly line that I drew there has to add up to 300. I want to maximize the area. Well, isn't this a rectangle? So I need to know length times width, right, to get my area. So I don't know any of it. So I'm just gonna call these two X. They match, I'm gonna call those X. If those are X, remember, he's only got 300 feet to start with. So if those are X, what's this side gonna be? 300 minus 2X, that's exactly right. 300 minus an X over here and an X over here, that's 300 minus 2X. So now I can do my area. My area is X times 300 minus 2X. Which is, now I'm gonna FOIL it and put it in order. So I'm gonna, not FOIL it, but distribute it and put it in order. So negative 2X squared plus 300X. Because I've noticed when the equation's backwards, sometimes people do it backwards. So my equation now is in the right order. A is negative 2, B is 300. And I want to largest chord. I want a maximum, which is gonna be a vertex of this parabola. So X will be negative B over 2A, which is 75. And I want to know the area. So with that 75, this will be 150. And so what will be my maximum area? 150 times 75. Which I have no idea if my arithmetic was right. Meters, so if my arithmetic was right, my multiplication, it's that. Length times width.
Where'd you get 150?
What's 2 times 75?
Oh, okay, 150.
And 300 minus 150.
Oh, I was, sorry.
Okay? Alright, so, Robbie, did you have one? Don't just, I mean, do you have something you don't know how to do? It's not.
Yes, for sure.
For sure.
It can be from homework or this review material.
We do want like the up and down ones, number 6 on the review 2.1 and 2.5.
Find an upper bound. Okay, now this is a little different. Usually the question says, is 5 an upper bound? This says just find one. So there are going to be millions of answers. So the problem is x cubed minus 4, 2, and 1. So what I would do if I were you is I would just pick a number, like I'll just use 5. And what am I hoping happens? No. All of these are going to be positive. So if I happen to get all of them being positive, then I have found an upper bound. So I got lucky. I picked 5, it worked. Could you pick 7 and it works? Absolutely. I don't know, you could try 3, I don't know what happens, I don't think 3 will work. But just pick a number. The idea is, when you do the division, everything has to turn out positive. And as long as it does, you have found an upper bound. What has to happen for a lower bound?
Alternate.
They have to alternate. So let's see what happens if we put in -5. I have no idea. Looks promising. It's gonna be big negative. That's gonna be negative, right? So is -5 a lower bound?
Yeah.
There are lots in both of those though. You just need to remember that means upper bound, this means lower bound. Okay, Peter, we're back to you. I thought you said you had another one already.
That was, that 6, he's picked mine.
He picked yours, okay. Lauren, do you have one while Peter's looking?
I have one. Oh, wait.
This was one I pretty sure I got wrong in the last test. Number 8 on the one we were already on, C.
I did a 5th.
I think I got that wrong in the last test.
Okay, remember that powers of I repeat themselves every 4. And I to the 4th is 1. So this is I to the 4th times I to the 1st, right? Well, that's just 1, so you don't even have to pay attention to that. So the answer is just I to the 1st, which is I. If this had been a 6, then that would be I to the 4th times I squared. Well, I squared is -1, so that I to the 6th would be -1. Just ignore every 4 I's, you ignore, because they make 1.
What's the answer?
Her problem, which is I.
Number 2 on that page.
Describe. Well, what shape is it, first of all?
It's a parabola.
Yeah, so tell me about the parabola y equals x squared. That's your BFF.
It's just a normal parabola.
It's a normal parabola, vertex at the,
Oh, is it just saying like if it's like left?
yeah. So
Oh,
what's
okay.
this one doing?
I just didn't understand what it meant.
It's
like,
moved left 1 and down 9, and it's going to be skinnier because it's stretched by a factor of 2.
That makes sense.
A lot of material in here. So it's skinnier because of the 2? It's stretched?
Vertically. Twice as tall, so it's getting taller faster.
Yeah, what? What does it mean when you say evaluate?
Figure out what it equals.
Okay, I was do 1 on the middle part of the tennis court.
Okay, so if my function is 3x squared minus 4x plus 5, and I said find f of 1, what would you do?
Plug 1 in for x.
So if it says f of 2x, what am I gonna do?
Plug in 2x.
Stop laughing.
Well, Peter, you do need to think a little bit. You know how to do this. So that's 4x squared times 3, that will be 12x squared minus 8x plus 5.
There's a lot going on in my brain.
Is there gonna be long division on the test?
I mean, unless you wanna do it. You can always do long division in place of synthetic division.
If we do the quadratic formula with that,
What?
with this one that we used to do, we do the
No,
quadratic.
this is the answer. It's done. It just says, tell me what you get when you plug in 2x.
Oh.
That's what you get. Only do the quadratic formula if it says solve, or is equal to 0 or something like that.
Can we do another one that's Like the first question on the homework, it's 5 on the additional review for test 2125.
The one that says S of P is 0.03.
Nice. And it says write the equation of, and then it has like the graph.
Oh, yeah, I know how to get up there.
Which one is it? Oh, number 5. Oh, I was looking at number 1. Yeah. Alright. So, first of all, we gotta figure out how many parentheses is that problem gonna have? 4. Because there are 4 x-intercepts. And those 4 parentheses are gonna be x plus 3, x plus 2, x minus 1, and x minus 4. Now, since they gave me a picture, I need to pay real close attention to what's happening. So, and when I say that, I mean, is there any bouncing going on in the picture? Because if there is, I gotta make that a squared factor, right? So looking at that picture, tracing over it if I need to, is there any bouncing on the x-axis happening? At the last factor, right? So now I'm done, except for the leading coefficient. Remember that parabola you just asked me about a minute ago? Right, well, I forget what they all were, but whatever that was.
Yeah.
This coefficient right here, which does what? It's really important. It tells me whether I'm up or down, and it tells me if I'm fat or skinny. Right?
Yeah.
So I need to figure out what that coefficient is. Well, how am I going to figure out what that coefficient is?
Plug in y and x.
I'm going to plug in the other point they gave me, which, what is that, 2, 10? Right? So we put 10 in for y, and 2 in for all of the x's. So 2 plus 3 is 5, 2 plus 2 is 4, 2 minus 1 is 1, and 2 minus 4 is negative 2 squared is 4. Multiplying it all together, it looks like I have 80. So n equals 1/8. So then I go back, and there's my equation. We're not gonna multiply something out to the 5th power, that would take a while.
So on that problem, like the one on the homework, this one just says write the equation. What does it say if we have to like distribute it all out?
It says multiply out, like the one in the homework. The first problem said multiply out, second problem said do not multiply out.
Okay.
Maybe kind of afraid to ask questions now, but
Okay, well, sometimes you need to think before you speak, but go ahead.
thinking.
Thinking is good.
Hey, what's the innovation?
Which one are you looking at?
No. Okay, yeah. Oh, wait. I was looking
What are you
at,
talking
I'm
about?
thinking. So,
Which problem are you talking about?
7 on the same page we just
On the
did.
same page, number 7.
Hold on.
Right before, no, a lot of people miss this, although I have done a bunch of them.
You just find n after doing what we just did, right? Because it gives you
Yes,
vertex.
but you're not, this is a quadratic function, and you're given the vertex. So you are not given, you're not given any x-intercepts. You don't build factors on this problem, because factors come from x-intercepts, zeros.
Yeah.
And they didn't give you zeros here, they gave you a vertex.
Yeah.
So we go back to the problem that he was just talking about. Now this is the 3rd time I've written this problem down. I may be changing it each time. But that's a parabola, right? Where is its vertex? -1, -9. So you need to know that. That you need to know, which was in our last unit. So if the vertex is at -1, -9, and that's what that equation looks like, then if the vertex is at -3, +1, doesn't my equation have to look like x plus 3 squared plus 1? Right? Now, I have to find that coefficient. And I do that the same way. What's the point I know? 2, 3? So 3 equals n times 2 plus 3 squared plus 1. So that's 2 plus 3 is 5, squared is 25. Subtract 1. And n is 2/25. So that part of it is like what we did before. But building this equation is different because we don't know the zeros. We don't have the x-intercepts. So we have to set it up in vertex form because that's what we know. Right? Okay, Peter? So, yeah, again, that's similar to what we did, but different at the beginning. Yep. I thought the music was gonna come on and I was gonna get in trouble again.